There's a motor that weighs less than a 7-year-old child, but it generates 800 horsepower. That shouldn't be possible. When Koenigsegg's CEO unveiled it, he didn't just show a new product. He showed the entire automotive industry something they said couldn't exist. Tesla's engineers went quiet. Ferrari's team started asking questions. And BYD, the company that's been dominating electric vehicle production worldwide, suddenly had a problem they didn't see coming. Because this isn't just about a motor. It's about a 22-year-old kid who started in a garage and refused to accept the word impossible. And 30 years later, he's built something that makes billion-dollar corporations nervous. The motor is called dark matter. The name alone tells you something's different here. But here's what they're not telling you in the press releases. This motor isn't designed to replace engines. It's designed to work with them. And that combination creates something the world has never seen before. Let me show you why this matters. Sweden, a 22-year-old named Christian von Koenigsegg, is standing in a garage with no budget, no team, and a problem that seems unsolvable. He wants to build the world's fastest car. From scratch, people told him what you'd expect. Building supercars is a game for multi-billion-dollar corporations. You need decades of experience. You need factories, supply chains, engineers with PhDs. You need everything he doesn't have. Christian's response was simple. If they can do it, why can't I? So he started taking cars apart, not to drive them. To understand what made them fast, he studied engines the way some people study languages. He learned engineering not from textbooks, but from failures. His first car was called the CC. He designed it. He built it. In that garage, when he finally showed it to the world, people realized something. This wasn't a kid playing around. This was someone who understood speed at a level most manufacturers never reach. But understanding speed and proving it are two different things. The automotive world had a king. The Bugatti Veyron, the fastest production car ever made. Untouchable. Christian von Koenigsegg built a car called the CCR, and it beat the Veyron. Suddenly, this small Swedish brand that nobody took seriously was holding the world's speed record. The entire industry turned its head. But Christian didn't stop there. He had a bigger vision. While other manufacturers were focused on making cars faster, he was focused on making impossible things possible. He invented a carbon fiber, monocoque chassis that was stronger and lighter than anything on the market. Then he created something called free valve technology, which eliminated the camshaft from engines entirely. Each valve opened and closed electronically and independently. More power, better fuel efficiency, less pollution. Everyone said it couldn't be done. He did it anyway, but then the world changed. Around 2010, the automotive industry made a decision. The future would be electric. Full stop. Tesla was rising. Legacy automakers were scrambling to catch up. Governments were setting deadlines to phase out internal combustion engines. The message was clear. Gasoline is dead. Electricity is the future. Every major manufacturer started pouring billions into EV development. Battery technology, charging infrastructure, pure electric platforms, and Christian von Koenigsegg looked at all of this and said, no, not because he didn't believe in electric motors, but because he saw something everyone else was missing. Electric motors have instant torque. Engines have range and power delivery. What if you didn't have to choose? What if you combined them? While the entire world was rushing toward one extreme, Koenigsegg went in a completely different direction. They announced they were building a hybrid. But not the kind of hybrid you're thinking of. This wasn't about fuel economy or being eco-friendly. This was about creating something faster, more powerful, and more intelligent than anything pure electric or pure gasoline could achieve alone. The car was called the Gemera, a 4-seater hypercar. But the Gemera couldn't exist without solving one problem first. Electric motors are heavy, really heavy, and the more power you want, the heavier they get. Christian needed a motor that was impossibly light and impossibly powerful at the same time. That's where dark matter was born. The name isn't random. In physics, dark matter is the invisible force that makes up 85% of the universe. You can't see it, but it affects everything. Christian chose that name for a reason. Because this motor doesn't look like much. It's compact, simple, almost unassuming. But what it does defies logic. 39 kilograms. That's how much it weighs. About the weight of a medium-sized dog, 800 horsepower, 1,250 newton-meters of torque. That's the power output of a massive V8 engine, from something you could lift with one hand. Now here's where it gets uncomfortable. Most electric motors operate on something called radial flux design. The magnets and coils rotate in a circle. It works, but it's inefficient and it's heavy. The dark matter motor uses axial flux design. Everything is arranged in a flat disk. The current flows directly, faster. No wasted motion. But that's not even the most important part. The motor runs on a 6-phase winding system. Most motors use 3 phases. Koenigsegg doubled it. What that means is this: even if 2 phases fail, the motor keeps running. No interruption. No loss of power. And because the design is so compact, they could fit an advanced liquid cooling system around the entire thing. Copper coils packed tightly together, with coolant circulating every second to dissipate heat. Instantly. This is why the dark matter motor doesn't overheat, ever, even when delivering full power continuously. But this only matters once you see what happened when they paired it with an engine. The Gemera has 2 power sources working simultaneously, a 2.0-liter 3-cylinder engine. It's called the tiny friendly giant. It produces 600 horsepower on its own. Then you add the dark matter motor, 800 horsepower, in a 4-seater family car. But it's not just about adding numbers together. It's about how they work. The dark matter motor drives the rear wheels. The engine drives the front wheels. All-wheel drive, but not the way you've seen before. When you press the accelerator, the motor delivers instant electric torque. 0 delay. At the exact same moment, the engine provides continuous power. There's no gap, no lag, just pure, uninterrupted acceleration. 0 to 100 kilometers per hour in 1.9 seconds. Faster than most motorcycles. Top speed, over 400 kilometers per hour. And here's the part that changes everything. The engine doesn't just run on gasoline. It can run on ethanol, methanol, or E85 biofuel, which means this hypercar is also sustainable. Koenigsegg proved something everyone said was impossible. You don't have to sacrifice performance for the environment. You just have to be smarter about how you build the system. But the real genius isn't the power. It's the intelligence. Tesla builds great electric motors. The Model S Plaid has 3 of them. Combined, they produce about 1,020 horsepower. The car does 0 to 100 kilometers per hour in 2 seconds. Impressive, but here's the catch. Each Tesla motor weighs around 90 kilograms. 3 motors means 270 kilograms. Just in motor weight, Koenigsegg's dark matter motor weighs 39 kilograms and delivers 800 horsepower from that single unit. That's where the advantage becomes impossible to ignore. Lighter weight means better handling, better efficiency, faster response time. Now let's talk about Rimac. The Nevera is considered the fastest electric hypercar in the world. It has 4 electric motors producing 1,914 horsepower combined. It does 0 to 100 kilometers per hour in 1.85 seconds. On paper, it beats Koenigsegg, but here's what the numbers don't show. Those 4 motors are heavy. The total system weight is hundreds of kilograms. Rimac compensates with sheer brute force. More motors, more battery, more weight. Koenigsegg went the opposite direction. 1 motor, half the weight. And when combined with the V8 engine, nearly the same total power. The difference is efficiency. Rimac uses traditional permanent magnet motors. Tesla uses radial flux motors. Both are proven technologies. Both are heavy. Koenigsegg is the only one using axial flux 6-phase design. It's lighter, it's more compact, and it's more energy-efficient. BYD is the world's largest EV manufacturer. They make excellent batteries. Their Blade battery system is one of the safest in the world. But BYD's focus is mass production, affordable EVs for everyone. Koenigsegg isn't trying to compete in that space. They're not building cars for the masses. They're building the engineering blueprint for what's possible. And that's where this story starts to get uncomfortable for the big players. Electric vehicles have 2 weaknesses that nobody wants to talk about: range anxiety and charging time. You can build the most powerful EV in the world, but if the battery dies, you're stuck. And even with fast charging, you're looking at 20 to 30 minutes. Minimum. Koenigsegg's hybrid system solves both problems. The dark matter motor can run purely on electric power for short trips, silent, zero emissions. But when the battery starts to drain, the engine kicks in. Not just to drive the car to charge the battery while you drive, no range anxiety, no waiting at charging stations, continuous power. This is why Christian von Koenigsegg says the engine isn't dying, it's evolving. While Tesla is building supercharger networks and BYD is focused on battery chemistry, Koenigsegg is proving that maybe the future isn't one or the other. Maybe it's both. The 2030, Viasio and Christian von Koenigsegg, has a plan. And it's not what you'd expect. He's not rushing to go fully electric. He's not abandoning the internal combustion engine.